So, I just did a video about the mole, so if you haven't watched that video yet, it might be helpful. And again, it's quite icy outside. We didn't have school for the past 3 days already, so if you haven't attended any of those online Pogo classes that we've had, it might be helpful that you watch that mole video as well. So today we did Chem Activity 7, which is the periodic table of elements. How is the periodic table organized? I talk quite slow, right? So it might be helpful as well if you turn the 2 times speed on this video, whatever. So we see this graph right here, and I already answered that right there because there is an arrow right there. I'll be talking about that as well. But we're seeing this graph, and when I asked the group that I was talking or working with earlier this morning, what do you recognize about the graph? Well, it's just like a bunch of up downs. If you didn't know how the table was arranged previously, well, to you it would seem like it's just an up down kind of graph, right? Okay, so we'll be going through all these questions, and yeah. So, on the y-axis, we can see the atomic radius. So what is an atomic radius? Well, if you know what a circle is, right? Imagine that this is a sphere, right? In a sphere, the point from one end to the exact point on the other end, that is called the radius, right? So we're assuming here that all atoms take up a spherical shape. So that's the size of that, right? We're measuring how far of a distance is it from this end to this end. So what would you say with the bigger the sphere is? Well, the bigger a sphere is, the bigger its radius. Oh, actually, let me take that back. That is the diameter that I was talking about. But a radius is halfway through. So from the very center of the circle across, that is what you call this distance right here is called the radius of a circle. So, the bigger a circle is, the bigger its radius, right? The smaller a circle is, the smaller its radius. So that's the idea right here. So number 1, use information from one of the classroom periodic tables to locate the element helium. We don't have a periodic table right here. I'm using one that's from the back of the Pogo right here, and write the symbol HE on the graph. What information did you use to make the decision? Well, this graph says that it's the first 56 elements, and helium is element number 2, so that must mean that the second point on the graph must be helium. So 1, that's hydrogen, 2, that's helium, 3, lithium, so on and so forth. Now the second question is asking use information from the periodic table again, and the one with an arrow. Well, the one with an arrow right there, if you count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is going to be neon, right? Element number 10, that's neon right there, number 10. So, number 3, in the y-axis label atomic radius PM. What metric system does PM stand for? PM is a unit of length. We know that it's a unit of length, right? Because we're measuring from one point to another. That's distance. That's a unit of length. So then PM, and in the metric system, SI units, M is meter, right? So the P stands for picometers. And that's a very small magnitude of number. And it's 10 to the negative 12, right? And just as a review as well, nano is 10 to the negative 9, and what is the other common one? Micro is 10 to the negative 6. So those are quite common. So I don't know if it's just a thing that I remember, but it's by the significance of threes. I easily remember them. Is centi? I think it's milli, right? Milli is 10 to the negative 3, right?
I don't know.
I think that 10 to the negative 3 is milli. Okay, so write the length of 1 picometer in scientific notation in units of meters. We said that 1 meter is equal to 1 times 10 to the negative 12. This is wrong. 1 picometer is equal to 1 times 10 to the negative 12 meters. So that's how small a picometer is, right? The mold that I drew here earlier smudged all over the place because I was just using my hand to erase all of this. Okay, so describe any patterns in atomic radius you see in figure 1. And, okay. So 4 and 5, that's kind of like for you to answer, but my explanation for this graph right here, yeah, is we mentioned earlier that it's just a graph full of up, down, ups and downs. But if you notice, what do we see about these peaks right here? The lithium, sodium, potassium, rubidium, and cesium right there. They're all the ones that are at the top, right? We said that it goes down, and then it spikes up. It goes down, and then it spikes up again. It goes down, spikes up again. Well, those spikes right there, peaks of those sudden spike, what do we notice about them? If you look at the periodic table, aren't they these ones right here? Lithium, sodium, potassium, rubidium, and cesium. So what actually happens, right, is as you go down, it's 8 p.m. you guys. So as it goes down, as you go down the columns right here, the size increases. But let's take into account those decreasing ones. It spikes up and then it decreases. Well, those decreasing stuff right here is when you go across a period, right? Hydrogen, helium, lithium, beryllium, right? We said that this one right here was neon. And what do we know? From lithium, it goes down to neon, right? The graph, it goes down from lithium to neon. Lithium to neon goes down. So what do we know about that? Well, that must mean that if we go across, size goes down. Does that make sense? Because with this peaks right here, or actually in here, the peaks right here, we can see them increasing. So going down the periodic table, it increases. Going across, the size decreases. So that's the general trend. And that should answer numbers 4 and 5 for you. Okay, number 6. Use the data in figure 1 to predict the atomic radius of element 57. So this is the first 56. So I kind of like drew in there 57, what I think 57 was going to be. So kind of in between 150 and 200, but leaning towards the 200 side more, right? So that should be element 57. And element 57, what is that? Element 57 is 57 is lanthanum. So based on the trend, we're going across, it must mean that it should decrease, right? And what do you know? If you look it up, that's for number 7. What is the atomic radius of lanthanum? According to my source, it was 187 to 188. And again, we're in units of picometers. 188 picometers. And 188 is in between these numbers right here, right? 150 and 200, and it's actually quite close to that 188 mark right here. I am not going to read this information right here. That's all up to you if you want to read it. But basically what it's talking about is the shells, right? So we know that most of the mass of an atom is centered at its core, right? And that would be the protons and the neutrons, right? For this class, it would be appropriate for us to think of them as spheres. The electrons in spheres, but that's not how they are actually arranged. And you're going to find that out when you take Gen Chem 2. They're actually not arranged in spheres. But for now, it's safe for us to say that. So, this is the core of an atom. And we know that an electron is too small, and the size of the electron is not very significant compared to the protons and the neutrons. And electrons, we kind of see them outside. They follow this specific pathway, or what we call orbitals, right? And it's also called shells. So these shells right here. So the ones on the very outermost shell, right? We're not talking about the shells that we find in the beach, but rather the shells in an atom. The ones at the very outermost, we call them the valence shells. And in the inner ones right here, I only drew 3 shells right here. So shell 1 right here are the smaller ones, right? Smaller. They're called the core electrons. They're in the core shells. And if they're on the outside ones, they're called valence electrons. They're in the valence shell. So that's all that's talking about. Now in Model 2, it describes how the periodic table is arranged. So going across, they're called rows or periods, I think. Yes, periods or series. But if we go, the ones going down, up and down, left to right would be rows, period, series. Up and down would be, let me write it right here, columns or groups or families. So these are interchangeably used when you go up or down. That's a column, a group, or a family, row, period, whatever. So number 8, in what shell are the valence electrons of hydrogen and helium? Well, they're going to be in what shell? In the first shell, right? Because this orbital right here is, again, we call it a shell, right? So the valence electrons of H and He, the outermost shell, are in the first shell. Aluminum, what about aluminum? Aluminum is on the third row. So that must mean they are all the ones in the third row are their valence shell are on the third shell, or valence electrons are in the third shell. Xenon, that's in the 5th row. So that must mean that they use the 5th shell for their valence electrons. Okay, from your experience, list some properties of metals. This is number 9. Each person on the team should also name one metal element. So I'm going to leave that to you guys, right? What is a metal? Well, someone in my group said that it's tough, right? Someone said that it was thick. Someone said that it was shiny. And I think that they could be appropriate terms to describe a metal, right? Have you ever seen a tough metal? Yeah, most likely. Have you ever seen a thick metal? Yeah, most likely. Have you ever seen a shiny metal? Most likely. Okay, what are the metals that my group used? We used copper, iron, gold, and silver. And they were right. Those are all metals. Okay, next, number 10. From your experience, list some properties of non-metals. Someone said that a non-metal must not be tough, right? It's not tough. Well, that's true. And if it's not tough, then it must be taking the form of a liquid or a gas, right? And in my group, the non-metals that we named were oxygen, nitrogen, carbon, and I think fluorine was one. Or actually, helium. So, you now are going to, okay, let's move to number 11. Locate. So we are going to locate the metals that we listed. And what group are those in? So when we observe, those elements are in this middle part. So the ones that my group used again are copper, iron, gold is this, Au, gold, and silver. So based on what our group came up with, we said that the transition, these are called the transition elements, by the way. The ones right here are transition metals. Must all be metals, right? But we don't really think about this row, or not row, but rather group, this column right here, as metals, but they actually are metals. We commonly think about what is that? Yeah, like the gold, like the platinum and stuff like that. And also here, there's lead and tin as well. Those are also metals. So for the first part, have all metals, only metals, it would be 2 to 12. Groups 2 up until 12. And that would be this group 1. We start here, group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up until where this zinc is. Those are going to be all metals. Now, so we move on to the next one. Which group have some metals? Well, some metals, we end at bismuth, because bismuth is also a metal. But nitrogen isn't a metal, right? So groups 13 up until 14, 15, those have some metals. Also this one, lithium, sodium, those are also metals right here, but hydrogen is not. So we're not taking hydrogen, but as a metal. But we're including this. It's a group that some metals. Now, metalloids are semi-metals because they get the property of metals and non-metals together. And that's we're now in problem number 13. And if you look at that, metalloids or metalloids are this ones that I have crossed out right here. The 6 common ones are boron, silicon, germanium, arsenic, antimony, tellurium. Now there's an argument if polonium and astatine are metalloids or metalloids, right? So they aren't sure because if those two are actually. So yeah, these are the 6 most common metalloids right here. I am going to leave question number 14, 15, 16, and 17 for you to answer. And make sure that you go through the reading assignment, the exercises, and the problems as well, because the exam is how many days from now? We have Thursday, Friday, Saturday, Sunday, and Monday. There's 5 days left before the exam. And if you haven't had your 4 points of extra credit on the exam yet, you still have time. Tomorrow's Thursday. I'm going to be in the S3C from 8 to 9:30, and most likely in the evening as well from 7 to 10. So that as well. If you come to the 8 a.m., if you come to that 7 p.m., that's 2 already. Friday, I'll be there from like before class starts, so that's 9 to 10. That's another opportunity that you'll have. And I'll also be there in the afternoon from 1 to 5. That's another opportunity. That's 4 already. And also Sunday evening, I have an SI, and in that SI will be what do you call this? Last preparations that we'll be having for exam number 1. So that's in Science 204, S204. That's another opportunity. That's going to be from 6 to 7:30. And then after that, we have that 7:30 to 10. And again, and that's going to be in the S3C, so that's 6. And the next day, I'm going to be in the S3C again from 9 to 10. So there's still 7 instances where you could come meet me and get your extra credit. So yeah. Ini, what do you think? Or Dorcas. Dorcas also took Gen Chem 1. What do you think? Should they go for extra credit?
Yeah.
Yeah? Well, my nose is all up in the camera.
Yeah.
Do you think?
Yeah.
Would that really help with the exam?
Yeah.
Okay, so what do you think about her exams? Are they tough? Are they... You can be honest. It's a personal video that I'm making, so...
It's tough.
It's really tough, right? One of the toughest exams I've ever had was Dr. Veldkamp, and if you haven't had that chance yet of experiencing that, well, this is your moment. So better prepare for that moment, right?
Yeah.
Tio, you've never had class with Dr. Veldkamp, right?
I just love.
Lab. Oh, lab is not as well. Her grading with lab is still crazy.
Yeah.
But yeah, but it's for everyone's good, right?
Sure.